almost everything is written in these days. Still have a bit of Node here, a little bit of other things here, but like a lot of our core stuff is in Java. Doing a lot of cool things too. So if you have any questions, plenty of Ticketmaster folks here. Rommel, Gil, Chris Smith, who's hiding the hash up there. So if there's, ask us about anything here. And I have spoken enough, so I will introduce Marco and take it away.
Hi, everybody. Welcome to the Los Angeles Java Users Group. We haven't met sometime last year, but I have a pretty good agenda for the next year. And hopefully, I'll be able to get a monthly meeting here again. And I'm glad that we have a healthy audience here tonight, because for a while it was actually really hard to get people. I appreciate that you're all here. I thank you for your time. And there's going to be good things to come here. So please support our JUG by continuing to attend. As always, I make room for announcements before we start. I want to know, I'd like to know if you guys could give a shout out for which company you work at, if you don't mind. I'm kind of curious what sort of crowd we have. Ticketmaster, Gambler Gaming, Gum, ProSum, any other companies? Commission Junction.
Public, based in New York, I work in Public.
Cool.
I actually work in Ruby. I don't like it, but
I like Ruby. So
Ruby on Rails.
I actually like Ruby, but I honestly get paid more money for this. So any other companies, or is that it? Now, I always want to say that LAJUG is a great place to network. I've had really good opportunities given to me through LAJUG as well, and some of my friends have as well, and colleagues. So if you're looking or you're interested, don't be shy about it. This is the place to do it, especially if you need a job. But I doubt everybody I doubt that's the case right now, because we have a really strong economy. So the next step is, well, first I'll go to this slide here. I want to thank our sponsor, Ticketmaster. And if you're interested in working at this place, you could go to email jobs@ticketmaster.com and they could handle it. They'll get in contact with you. Aside from that, are there any opportunities that people want to mention here so that the developers that are looking could talk to you?
Recruiters. I know you said you hated Ruby, but just in case you change your mind, but I'll start out as well. You have friends and family. Yeah, sure.
Thank you very much. Any other job? Wait, which company? Gum. Okay.
Yeah, so they're looking for a senior level engineer. Guess who'll be working with me? Probably a good idea. Yeah.
All right. Go ahead.
So I have a small family business, some help creation of web-based software, especially strong kind of.
Okay.
So if anyone is interested, I need some help. Because I'm a C++ Windows programmer, so I'm trying to do the web thing and give me some.
All right.
Okay.
Anybody else? So LAJUG is always looking for presenters as well. Oh wait, one more?
I'm looking for work.
Oh, yeah, there you go.
So fun.
Yeah, talk to these guys. That's
I'll look in the
awesome.
fall.
That's right. I mean, I used to say if you're looking for work, raise your hand. But this economy, man, it's ridiculous right now. Anybody that wants to work will. You wish you was?
I want Jody to get there. This economy, great.
A part of this economy is going to get your introduction by the time it gets all the way up. You might have to
That's right.
It's gonna be the
Guaranteed.
same way. Like, we went from like looking to hire like who's looking for jobs, and it was like no one ever.
And there was an article today, even that was marked on Google News as there's been so much people are changing jobs right now because it's so. And that's a great sign of a healthy economy. That if you want to change, now's the time. I'll even say that I want to know what's out there. So please let me know. I heard all of your stories. All right. Oh yeah, I was saying we're always looking for presenters. If you have a presentation, or if there is a particular topic or presenter that you want me to get, please let me know. You could talk to me personally or find me on the LAJUG website and contact me through there. Because I want you guys to be interested in what we see. I don't want to be the only decision maker on that. And all right, I'm going to start with the presentation now. It's 7:10, so. I forgot how to do this. Oh, there you go. Okay, bad things happen. Recognizing common pitfalls in Java concurrency programming by me. The original title of this presentation was "It's the Mutable State, Stupid," which is actually a quote from this book. And I have to say that almost everything in this presentation is in this book, and you'll see the references with the little numbers. It's in my notes as well, telling you like which page that information is from. If you haven't picked up this book, Java Concurrency in Practice by Brian Goetz, I highly recommend it. It's one of the best reads out there on Java concurrency programming. And I wrote this presentation because I kept on finding bad code, and I didn't want to have a personal conversation, a one-on-one with a person over and over and over. And I thought, well, you know, these things are happening all over our code base. Maybe I need to present on what to avoid when you're writing the code so that they're all aware of it, because there's lots of knowledge that people don't have. The rules are different in concurrency programming, and we'll get to that. I always try to add a little humor. In the beginning, the programmer executed a program that had only the main thread. The program could only do one thing at a time. Then the programmer wrote code that there be two threads. And the program now executed things in parallel until something bad happened. The point I'm trying to make here is the rules in concurrency program are very different than just single-threaded code. And I'll give you a very simple example. Let's say you have two threads, thread 1 and thread 2 down here. And they're accessing an unthread safe account object. If the timing is done right, things could go really badly with this scenario. So I will give you a simple interleaving analysis problem that demonstrates that. This is interleaving analysis with these little blocks like this in timed order, or is a technique that people use to explain to other people why certain code might not work correctly in a concurrent situation. So let's say your account has $500, and you earn a lot of money and your company is trying to deposit $25,000 into your account for bi-weekly payroll, and you're trying to withdraw money at the 4 a.m., $300. If it's not a thread safe object, you're both going to read 500 at the same time. Your company is going to deposit the money, but you're going to deposit 300, but you still have the read on the 500. Your balance will be 2,500, but this read is actually going to override it, and now you only have a balance of 200. The next time you check your bank account, there's only $200 left. You say, what happened to my paycheck? Bad concurrency code could easily lead to a situation like this. And this is what a thread unsafe object looks like. It's really simple. It has an account, a change balance method to increment your balance, another one to get the balance. And if two threads have the same reference to this class of memory, shared memory, which is mutable state, remember it's the mutable state stupid, things could easily go wrong. Now, in this presentation, I'm not going to go over the solutions necessarily. I'm just going to try to help you read the code so you could recognize where things can go wrong. In this situation, you would need a synchronized block when you're referencing the account to actually have it run correctly. So I'll say that, but I'm not going to write the code because there's too many situations. So, but I'm going to dive a little deeper into this class because to the untrained eye, this looks like a very simple one-line method. And there's actually a lot more going on behind the scenes there. People have to understand all the computations that a computer does just to handle this one method. And one thing I did was I compiled this class, and then I ran the Java disassembler on it. And that method actually has 7 lines of code. Is that 7? No, yeah, 7 lines of code in it when it becomes bytecode, which is sort of like, kind of like an assembly language. And this is just the Java assembly language. This is not even translation to machine code. So when you have multiple threads running this method on the same memory space, it's actually not just one line of code. It's more like whatever that blew up to into machine code. So you need to keep in mind that even a one line is really a lot more in machine code. That's not in this book. But I do have to say that concurrency programming is good things can happen with it. It's not just bad things. With concurrency programming, you could exploit multiple processors in your machine. Some problems are easier to model. Let me give you an example of that. Now, this is maybe not a good design for a server with a heavy load, but if you have a server socket and you accept a connection, if you just throw it in a thread and launch it into space, and that's very easy to do, and it's very simple to model. It's not very scalable, but trying to do that with multiplexing I/O is actually, even though multiplexed I/O is more scalable, it's harder to write code for multiplexed I/O than it is to just throw it in a thread. So it does lend itself to a simplicity of modeling. I just used that exact example for handling of asynchronous events. It's the same situation there, which I just described for the simplicity of modeling. If you're writing a UI, for example, Swing, use multiple threads in there, and the what's it called? There's a particular queue that they use for handling events and thrown into one thread. I forget the name of it right now, but pardon?
They call it
I couldn't hear you. Sorry.
just message passing.
Okay, message passing. But there is a thread pool used by the UI so that the responsiveness remains there. When I was a beginner at programming, I wasn't aware of how to take advantage of that. And you have an event handler that has a complex computation. The UI would just freeze there. But if you throw it into another thread, it doesn't freeze there. But with concurrency programming, you take certain risks. Thread safety is one of the risks. Thread safety basically is referring to whether an object is able to protect itself correctly when multiple threads access it. Liveliness, that's the ability for the threads to remain active. When you do concurrency programming, it's actually quite possible for a thread to reach a state where it will never become usable again. And that's something you want to avoid. Performance, well, there are situations where concurrency programming can make the application perform a computation more quickly. There's also times where it doesn't. You have to be careful when you decide to do that. But a thing to keep in mind with concurrency programming is there's a lot of frameworks that we use, and there are threads everywhere in them. Even when you launch a JVM, there's going to be the main thread and another thread for the what's it called? For JMX, for example, and garbage collector. Those are all two different threads that are also running while your application is running. So there's no such thing as a single threaded Java program, actually. Okay, right now I'm going to focus on bad thread safety. If you have multiple threads accessing the same mutable state variables without synchronization, and they're both mutating those state variables, your program is simply broken. It becomes non-deterministic, and the results that you want are unpredictable at that point. Really?
Well,
Wait, you wouldn't?
in a lot of cases,
Yeah.
right? But it depends on the requirements, what that variable is.
I haven't thought of a situation where I wouldn't want that. If you could give an example, that'd be great.
So if you had a place where you just wanted to be able to get a metric that was correct, state system at 8 point time, not knowing for sure what point in time it is, and having an integer that threads just right into like the last value, the last sequence number, right? If you're non-deterministic, what sequence number you got that? But the guarantee would be that it was a sequence number that had.
Well, it could also.
They have requirements such that there isn't a requirement.
But I'll say this: it might be 0. It might be the initial value was ever initialized with, which would be 0 if it's not a final variable.
Right. But there's definitely the issue of safely initializing actually. Yeah. Right. There's a lot of cases
So if it's not a final variable, the first variable that value it receives will be 0 if it's an integer. And if you don't have proper synchronization, it might be 0 everywhere you access it, except for the places where it's updated. Only in that thread will it have that value.
That's right.
And I don't know if that's. I've never written code where that's a good thing. But okay. So one thing we were talking about right now is a concept called visibility. If you don't use proper synchronization, the value that is assigned to a variable might not be visible in a different thread. There might be race conditions when there's thread safety as well. Unsafe publications, which I'll get into later. Improper construction, which I will also get into later. From my point of view, appropriate synchronization provides deterministic rules for sharing memory. I think that's an accurate statement. I kind of am scared to use my own words sometimes because this is such a rigorous topic, actually. All right, so this is an example of bad visibility. And I have to explain this, that this is actually might not yield the results that they want. So imagine you have this reader thread class, so we sent a thread. It has a Boolean called ready and a number. And so guess what will happen when this runs? Somebody raise their hand and answer it. I think, what could go wrong with this? Anybody want to take a stab at it?
Ready might initialize to false, and then when you set to true,
Forever.
Yeah, never update.
All right, so this might be an infinite loop here. That's a real possibility. It's non-deterministic because it's not a thread safe class. And well, let's say it does get past ready. It might print 0, not 42. This could actually happen. And it's hard to test these sort of things. That's one of the things about concurrency programming. Because if you run this, it's probably going to print 42. But actually, no, I take that back. Not this one. Yeah, it'll probably. I don't think it'll stay in the loop, but because it does try to help you, the JVM, but there's no guarantee. That's the thing. I believe it will context switch eventually, but I don't want to write code that goes on my wishes, not on actual fact.
Context switch follows thread, but ready makes it constant.
That's true.
You must mark it down.
So this is an example of visibility. Hi, Oliver. It's okay. All right, this is a tricky one. This is called an unsafe publication. There are two things that could go wrong with this one. Anybody want to take a stab at it, or should I just point it out? Well, I want you to imagine an instance of unsafe publication being created and then being shared, well, declared, I should say, declared, and then two threads accessing it. The instance of unsafe publication. One of them calls initialize, and then later on, they call it assert of sanity. So what are the things that could go wrong with this? There's two major issues with this.
The folder might still involve.
That's right.
Technically, it's not.
So that's very possible, actually. Because this is not a final field, when this is constructed, it ends up using the default constructor before it uses the subclass constructor, which means the first value it's going to receive is 0. If another thread calls a certain sanity from a different thread,
The way you have the initialization. Never see it.
But this guy has, it's not completely constructed. It could still call assert sanity.
Oh, well, it's still not.
And
Totally.
this will be 0, and this will be whatever value they have in there. The value won't propagate to the other thread.
It would be assigned yet. Oh, it's
No. You see, they both have a reference to holder, and initially they're going to be 0, the n. And because there's no guarantees on n, it might not propagate to the other thread, that value, the cache. The cache might have 0, not what's in the constructor.
The holder object has to be correct.
It's going to get 0 first.
They can allocate the counting the reference. No, what happened is you have this.
They have a reference to unsafe publication.
Have a reference. They have a reference. Like you can have a reference.
So if initialize is called in one thread, and the other thread calls assert sanity, that's where the error could happen. And this could be 0 is equal to the value in the constructor. It's in this book too. So if you disagree with my example, you disagree with all of these names, including Joshua Block. This is a really tricky one, but this is called an unsafe publication because you're leaking your reference. You're leaking your reference. You didn't encapsulate it, and multiple threads that have access to it before it's really ready to do anything, and there's no synchronization in it as well. So, okay. Now this is another example, and this is probably the most common error that I see when I'm reviewing other people's code, and I see a concurrency error. I have a name for this one. There's no official name for it, but I came up with a name for it. I call it the sleep and pray anti-pattern. And the reason I name that is many times people make an instance of something like this thing called a state machine. And they do some large complex computation. This one's not complex, but often it is very complex. And that's why they throw it in another thread. Then they go do a bunch of other stuff, and they add a sleep in there because they want to pray that this one finished. And then they say, well, it should have been finished by now. It should have been done by now, so I'm now going to call my step 2 of the whole operation. Now, I really simplified that example for the case of this presentation. This is really hidden in much more complex steps in real code. But I see this a lot. And the bottom line is, a sleep will never, the sleep is the wrong construct to solve a race condition of this sort. It's not what you use. You're supposed to use conditions or signals or a latch or what's the other one? A semaphore.
Lucky if they use sleep. I see. And going like, oh, this one's harder than the other one, so it will always finish. Or yield the other one. Build and sleep. That's what we do. Yeah.
But I see this one a lot.
Yeah, no. It never works.
Well, the thing is, it does work some of the time. You just don't know when it's not going to work. And your test case probably will work. All right, this is what I call an unsafe encapsulation. And this is courtesy of my coworker, Zach Winter. He brought up this example to me when I was writing this presentation. And this looks like thread safe code, but it actually isn't. Just imagine you have 2 threads that have an access to a wallet. And they don't do any other synchronization except for calling that shared instance to get the balance and change the balance. Well, in between those calls, they both have ownership of it. They both swap ownership of it, and they're changing values in the middle of the computation. And so, once again, like my first example, you could end up with a lot less money than what you want. The proper solution for this is you use the synchronized block on the reference, don't just depend on the synchronized methods. That doesn't solve the problem for you. Do you guys understand what I'm saying? Okay, so let's pretend I'm a thread and you're a thread. And we have a wallet. And there's $100 in my wallet. There actually is. And we both have a reference there, right? I get the balance, 100. And you get the balance, 100. But I don't own the wallet yet. I just have a reference to it. And then I want to, wait. Well, exactly. We both have 120, not 140.
Yeah, all the methods should be synchronized. All the methods should be synchronized.
Well, they are synchronized. I shouldn't let you change my value when I'm using it. That's the thing. I guess so. Yeah, sure. I mean, what I tried to do was I tried to title above it with the class telling you the example that I'm trying to make. And then, but yeah, so even code that looks thread safe, depending how it's used is not. And the consequences could be really bad. This is another example that I see a lot. And really, it's just a twist on it's really a twist on this racing vision over here that I mentioned earlier. But this is what I call a bad latch. This one actually has the threads in here. So you have a state machine with a countdown latch. And the countdown latch is null, which is a mistake already. And then you start, I don't know why I have the for loop in there. That must have been a bug, but you have the start. Oh, because I make it zero, I make it null here. That's fine. You have the start. Wait, I didn't update my code. I'm sorry. This is actually not the code that I wanted. Well, let me find the real example, because this actually is safe. This will actually work. So, bad latch. Presentation mode. All right, you guys can see that, right? Okay, there you go. So this one will fail. You have the start in one thread, step 1, and step 2 in another thread. You sleep and pray in between your values to do, and then you call the wait until finish method at the end. Well, unfortunately, the latch might be null because there's no visibility guarantees on the latch, and the assignment of the latch is happening in a different thread, and so you'll get a null pointer exception, which would be a legal state exception instead of the real await that you're hoping to get at the very end. But on the other hand, whenever you have a countdown latch and you don't assign it a final value in the very beginning, you're taking a lot of risk that it will never actually be correctly assigned, because a countdown latch is an object that is meant to be shared by multiple threads in the first place. So if you don't have a non-final countdown latch in your code, if you're going to initialize it in another thread and use any of these other threads, it's really risky. Now, the original example that I had here actually would work. And the reason why, and I was talking to Zach about this today, because this was in my original presentation that I gave at my company. The reason why this would actually work here, maybe if you take the for loop out, so I think the for loop might ruin things. Okay, without the for loop, this would work. The reason why, even without the for loop, I think it'll work. Yeah, it would. Because this start is happening before the thread has ever started. So everything that actually happened here will get propagated to the creation of another thread because it happened before. And the JDK specification actually guarantees that. So I actually had to change my example to this one to make the point. This one would actually work. But actually, my walking you through it will help you understand, read the code, I think. So I'll still go through that. So this is what you call a bad counter. My bad counter example. Okay, who could point out what's wrong with this? That's right. So can they call this at the exact same time then? Yes. When you are using a synchronized block, you have to use the exact same instance to synchronize with. In this situation, they're using a counter. In the situation, they're using this. Because they are different objects in memory, different monitors, they both can execute at the exact same time, overriding each other's value. And this is just a simple increment method. So this is really bad code, actually. But one thing that I do when I review people's code is I look for mutable state that is shared, and I have to check if it's using the same monitor or object to synchronize upon. And a lot of people don't know this, and so it actually happens more often than you think. I spent a lot of time writing this dumb graphic. I was just trying to imagine what a bunch of different threads accessing memory might look like. People always ask, why did you make these diagonal? And I thought, well, because it looks cool. That was my only answer. But imagine each of these arrows, as this legend says, being a thread, a dotted line being an access to memory. And whenever you use a framework or you write your own system, you have to account for the threading in that system. And I don't know of any tools that help you with this, but you have to basically do a walkthrough and account for the different type of memories that you have. Immutable memory, which is inherently thread safe. Mutable memory, which is dangerous if it's accessed by multiple threads at the same time. Atomic variables, which are safer. Well, they're safe. Volatile memory is also, it's always visible, but there's no, it's not transactional in a sense. Synchronized memory, which is like a transaction, and the concurrent collections. I basically look for these type of variables that are shared, that are used by multiple threads, and of course focus mostly on the the volatile and synchronized blocks, and sometimes concurrent collections. Usually, atomic variables and mutable memory is, well, mutable memory is always thread safe, and I haven't ever seen any issues with atomic variables either. Those are very thread safe constructs in the language. But it's, as I wrote down here, it's the developer's responsibility to determine which threads exist within an application, what the mutable state variables are that are shared between them. And this requires an understanding of how the frameworks that you are using use threads. Tactics. So if you write a stateless system, which is really hard to do, unless you're doing pure functional programming. But if you favor statelessness, meaning like you use parameters for values, you maybe use, there's actually this mantra that Golang uses. They say share by copying, not by sharing. Is that what they say?
Yeah, yeah. Share by copying, that's actually like trying to get one of the, there's a whole school of that every thread is process share by copying.
Fair enough. Favor immutability. Mutable objects are always going to be thread safe. Encapsulate synchronization correctly. That doesn't mean you don't need synchronized blocks. You still do, as you saw on my wallet example. And another approach is don't share memory between threads. It's a really simple one. Harder to do, but that's a technique. This is a tactic. Okay, now I'm going to talk about bad thread liveness. Did I spell that correctly? Liveness means the ability for the thread to continue and be, usable. The things that could the bad things that could happen with a thread are in this following list: deadlock, which are, maybe I should have indented this, but there's lock ordering deadlocks and a simple deadly embrace situation where I'll show you a chart about that in a while. Resource deadlocks, such as waiting when thread A holds a connection to database D1 while waiting for connection to D2, and thread B holds a connection to D2 while waiting for a connection on D1. That could happen in a system, and they will be deadlocked right there. Starvation. It's when a thread needs a resource, but it's perpetually denied it, and so it cannot actually make any progress. And live lock, which is a situation that I've never actually experienced in my own code, or at least I was not aware of it. But it occurs when a thread is not blocked, but it cannot make progress because it keeps on retrying an operation that will always fail. Actually, I probably have seen that then.
That one you gave me example. Wow.
But basically, if you have a retry operation like, hey, connect to the database. Database is down. Okay, retry. Well, you're still alive, but you can't make any progress. Okay, so this is an interleaving diagram of a deadly embrace. A very simple example. You have thread 1 gets lock S, thread 2 gets lock Y. Now, thread 1 tries to get lock Y, and thread 2 tries to get lock S. And in that really simple scenario, there will be deadlock. Now, I never actually seen code like this. No, actually I have. And this is the lock ordering deadlock. Let me try to see if I can remember how I saw it. No, are you guys familiar with the observer design pattern? And so imagine like you have a bunch of observers. It's like an event handler, right? And let's say you have like 3 layers of this, and you're notifying your observers, and then those observers notify their observers. There's a loop back in the graph, and there's locking involved because they're worried about concurrency issues. Well, that's almost the same as this. So you have 2 objects, left and right. You call the left-right method in one thread. You call the left-right method in another thread. And the way they acquire these monitors will deadlock. Get their calls at the same time very easily. This one is actually very complicated to solve. This is called the dynamic block ordering problem. But basically, if you have 2 threads call transfer many at the same time, as I say in the comments up here, one transferring from X to Y, another one doing the opposite, this will also be a deadlock. And the thing that's tricky about this is that this really looks like thread-safe code on the surface. But it isn't. And the actual solution to this is it's about 3 to 4 times longer than the code that you have here to handle the situation properly. I'll let you guys take a look at it during the break if you're curious, because this is a surprisingly complex problem to solve. I would consult the book if I were to solve it.
Would that generally bad practice to synchronize on
I don't think so. I think this is just done incorrectly. I don't think it's necessarily a bad practice to do that. Consist.
The order unless you have like a sort order that you always use.
Yeah.
I don't really see code that tries to do things like this quite often, but being aware of it is really important, because now that you've seen this presentation and you see nested blocks, you're gonna be like, oh shit, let me go look up this book to see if it's done correctly here. Yeah.
There's a callback to the open possibility that
I see a lot of people avoiding kind of like all the good concurrency libraries that are out there now. Because I mean, I don't see a lot of low-level code like this anymore. It's, you know,
concurrency stuff like how long the data.
yeah, or the Doug Lee old stuff.
Actually, this is very good. You don't even like always had. I'm not knocking that. Like, I think a lot of us now always had some of the W collect stuff. And I wonder, like, I don't know. I'm asking.
I think that the reason why you don't see it often is because Java is so popular on the server side, the back end, and the framework usually passes a parameter for you to use. You're not aware of which aspects you're not actually sharing the value unless you make a static final. Well, if you make a static variable or even a field where it doesn't belong, like a servlet, for example, a servlet shouldn't have fields. And
Well, I mean, that's where, but do it. It might be uncommon.
I mean, you'd have usually the only like shared variable in a servlet is a database connection pool, which is using a thread safe construct.
I think that's servlets a common thing. Also server on reactive sense. Like a variable. That's a variable. Like we would try to rely on a local variable thing, not realize like change.
Yeah, that's one thing that terrifies me about Spring. Because when things are in the context, I don't really know Spring's guarantees on the thread safety of a value in that context.
I think that's your point before. I think the concurrency frameworks, maybe it's like we're using builds. Oh, you would not. I don't think anyone would use it. Like, is anyone 8 and 5? Yeah. Like, no one's done that, right? It's going to do that anymore. Synchronized blocks still.
But we use signal. But we use signal and condition, though. I mean, is that what you're saying? Do we use signal and condition now instead of await, or?
Like the executors framework, lots of stuff. Programming, executors.
Yeah.
That I think is much more common. Anyone writing on it's just very uncommon. I'm not saying that under the hood things aren't happening. I'm just wondering. Actively discouraged to use. I just wonder. I don't know.
I don't know if it's discouraged. Well, yield and wait, yeah, but not signal and condition.
The other thing is also this, actual context. Behavior. The whole point of the transaction is to operate all of it. From one count to another direction. So that enforces that becomes the materialization. That's why you
Right. A lot of extra stuff. No, I think the game version stuff doesn't work.
all the time.
But I think a lot of the programming languages don't have credits. Right? They don't rely on credits. Right?
So where I work right now, it's as one developer said, it's a concurrency boot camp. You have to. A lot of these scenarios that I mentioned about come up a lot, and I think, from my point of view, I don't think I could actually talk about it in recording this, but you have to be very knowledgeable about these issues. I think if you go to these SQL code bases, at least when they initially launch, you'll be terrified of what you see there. Once they get a little battle tested and the open source world has had more eyes on it, a lot of these issues will get fixed. But for a lot of these things, they just like have a gung-ho, let's get it done, fail fast approach, and they ignore this stuff. And then later on, somebody looks at it and says, oh, look at this error you have here, and they fix it, and it becomes quality code later. But
That's absolutely actually regularly our product by distribution. He actually has a
interesting.
Every database, every almost every even ones that are pretty well established will pass
Hold on. So we're gonna take a 10-minute break right now. No, this is the time for a 10-minute break. You know. I'm starting my timer now. Stand up. It's break time. Stretch.
There and there.
Think about set discovery.
Are you guys learning?
Yeah.
Okay, good.
They still have they're fixing the scenarios that will lead to this becomes a memory book, so let's fix that. So fixing that. Yeah, that's fine.
Some living versus there's a loss. It was fun. Actually, it was a lot of fun. I wouldn't have come back except stuff. So, Oracle before. What's pretty good for me is to have this big job in my resume. So, I guess, but I think Oracle SQL Server pretty well. That's the impression I've got. I mean, the job documenting recruiters is SQL Server, Postgres. Yeah, Postgres. The PLSQL, the Oracle user groups are not even meeting.
They're really losing it to Microsoft SQL Server.
I don't know. See, I don't know.
I think that it's kind of a weird thing because the recruiting world on databases is all corporate because they just have so much, code.
I always
They're get off of it.
Do you know what to get the
They're stuck there.
How would
So I think a lot of their need is kind of maintenance and constant maintenance of the systems. And I know that here we still have a fair amount of Oracle, but we phased it out. Nothing new has been added to Oracle for a long time. We have like almost everything that is serialized these days is either going into MySQL or Dynamo or Cassandra or some other kind of technology. And there's very little business logic in our databases, right? I mean, it's almost all just serialization. So I would say that my perspective on that is that a lot of mid-sized companies use Microsoft over Oracle, and so the growth in demand for EDAs is probably driven more by those mid-sized companies. And I think that even in some large companies, Microsoft might have made some wins because they've got Azure and other places where you can develop using Microsoft technologies and then kind of export it into a cloud. So I wouldn't be surprised if that were the case. I'm just not in touch enough with it to validate what I'm saying, right? I can guess at why it might be true, but I don't know that. Well, if you think about it, Oracle's got a huge kind of like install base of very large corporate clients that use kind of like the traditional databases. And they've got a lot of apps. So like where Oracle's grown is they sell a lot of like,
CRM
things built on top of it, right? CRM and ERPs and all these things. And so I think that's where a lot of their revenue stream is. And pure like EBMS, RDBMS is probably a much smaller slice of their pie.
A lot of open source.
Yeah. I mean, they bought MySQL because they wanted a footprint in open source. then they still get lost.
But it's the feedback that I'm getting is it's really just for me, I've been working in Asia for 7 years.
So you're using like what was common there.
Well, no, I was actually teaching at university. I was doing a program.
Oh, okay.
And so now I'm trying to get work, and it's a big problem.
So what is your core tech stack? Is it Oracle?
Yeah. I used to. I did for instance, I did CSAT, a lot of the CRM for Apple. The Apple stores, the iTunes, there's no more. And now, of course, there's some other stuff that they've done.
Yeah.
But the problem is that, I keep getting recruiters and they're just telling me, oh, MySQL. And I have this, I guess I have this horrible smoothness. I don't really want to work MySQL.
That's not hard. I mean, it really depends on.
I just don't like it.
There's a lot more there, but standard DBA jobs are different. It's a lot more about operational DBA rather than like. So
I'm a data warehouse.
Yeah, so data warehouse, that's all moved to a big data platform. That you got to kind of get on the bag and I could be a specialist and use something like Vertex, or I could kind of go and learn a lot of the Hive, HBase, all those types of technologies and how they distribute big data stuff in big warehousing. The Star cluster, the Star topology, and ETL pipelines are all kind of like different. Now ETL is a lot of it is just smart. So like technology, some platforms. We had a company here, Stream Set. I think it's a fantastic looking ETL kind of provider, but so much ETL is like written in Python. They're just ETL. Then the data sets are either so small you can run them on a piece of computer today. So what used to be a big data warehouse, or so large that you need like to really move it over to something that's very distributed.
Yeah, what I'm doing right now is running R. The thing I learned from Python, I don't really like one thing I don't like about it is that the style is
I mean, if you want to work within that world, R and Python does. So you should at least be familiar with tools and languages that are in common use before you kind of buck the trend, because it'll make it harder to fit into practice. If you wanted to kind of branch out on your own, there's a lot of smaller companies that don't have it. You can build your own there. Like you can say, I can pick my tools and do whatever because I am a data guy. And so if you walk into a big practice, you got to kind of use it to something hard to it'll make it easier to hire for sure. And
you're saying Python or group versus
that whole stuff. I mean, R Python, I would say if you're going to use processing frameworks, Smart, that's like what everybody about you.
You're also
variety of different visualization and back-end stuff. But you can download like packages like Origins, which have like kind of like big data interface, right? And there's
I installed it.
Yeah.
I did it. Thought it was not very
well, that's why people support more distros that have all those tools kind of pre-built.
Yeah, no, I haven't installed it. I was able to get it working on Linux.
Yeah.
It was Debian. I remember right. Yes, Debian.
Yeah. So I mean, I would say if you're going to go into the market and you've got the time to learn, you might as well just figure out what they're really using and kind of talk to people in the field and say what's going to stick around for a few years, so you don't like get on something that is trending. Right. So you're going to make an investment. learning something, you might as well make this as learning something else at least 5-year window. Really wide availability.
Yeah, I mean, I guess I'm gonna try to less.
Those are, that's where.
Oh, this is for the last one.
Definitely, we use a ton of it, and most companies I know use a ton of it. My brother works in the world on the data side.
The hash for the instances of
Yeah. Learn what, swallow your pride on what you like and don't like, and let's learn what they do. To make your at least market.
Okay, everybody.
Once you're done.
We will continue the second half of the presentation. It'll be done within less than an hour, actually. So, we finished this one. I was just showing them the solution, a solution. Okay, so Leibniz tactics for threads. Acquire locks in a fixed global order. If you have to acquire multiple locks, lock ordering must be part of your design. Always ensure that you acquire in the same order. Actually, we had that issue a lot a couple of years ago, didn't we? When you have a dynamic lock ordering problem, you use system identity hash code. That's one of the solutions. That's the only solution that I'm aware of, actually. If there's other ones, I'd like to see them. This is something that I think of mentally when I am reviewing code, but I think of threads as the nodes of a directed graph whose edges represent the relation of thread A is waiting for a resource held by thread B. And if there's any cycles in that, well, that's what you need to weed out. That causes deadlocks. And just anywhere you see synchronized calls thrown in a cyclical graph, you're really asking for it. Strive for open calls. Now, when I first read that, I was like, what's an open call? That's basically using the synchronized block as opposed to the synchronized keyword, or something like a lock object from JDK5, Java Eats Up Concurrent. You don't use a synchronized method, but you use the smaller scoped blocks. One thing you can do as well is you could use try locks that have timers on them, and that could help you avoid deadlock. And when you do actually run into a deadlock issue, I mean, the machine doesn't tell you I'm in a deadlock. It just doesn't seem to be doing anything. You're like, what the hell? And one way to prove it is if you have access to the machine, you find out which process is running. You can use JPS for that. And then you call JStack on that process. And it'll give you a thread dump of all the threads and their running state. And you could detect a deadlock there. It'll give you like a small stack trace for each thread. That's a very handy way of analyzing where things are stuck. And if you've ever analyzed a deadlock, I'm sure you've had to resort to that.
So the identity hash code one really just need a way to be able to sort the object from the hash.
Right.
Identity hash code has that property.
I see. I see. So the tiebreaker, though, is a little tricky.
Yeah, you can't have ties. So what you do is two of them are equal, like you can't be part of the lock. But there's lots of cases where like an ID value that you just sort of.
Thank you. I'm not aware of any dynamic lock ordering scenarios that I've had to deal with. I've never seen it in my code, but I'm worried to run into it now. Okay, so now I'm going to talk about performance and the bad things that could happen with performance and threading. When you have multiple threads, they have to coordinate their logs, their signal, the memory synchronization, and multiple threads also causes increased context switching. And there's a cost associated with the creation and the teardown of a thread and all the scheduling that the OS must do. I guess context switching is one of the bad guys here, but it's also one of the good guys. With context switching, you're allowed to preempt one thread and do multiple things at the same time, but it does impact performance, and that's why I'm talking about bad thread performance. You have too much context switching. There's a lot of time spent doing the context switch and not the actual work, and that's a bad thing. There's also a cost associated with the synchronization of the memory at the CPU level and the caches that it has to the various threads accessing memory. But this is an important point to keep in mind that I'm going to stress right now, so I hope you hear me. If you don't have contention on synchronized code, it's going to run fast. It's only when there's contention for the same synchronized code that performance is impacted. So don't be afraid to correct your code and add synchronization to it when you know it's not contended for. Because if you don't add that synchronized block or synchronized code there, it won't be thread safe anymore, and it will fail eventually.
Counter to that also is if you know you're going to have try to use a comment instead of
True. So what he's basically saying, which was really clearly stated, but there are non-blocking ways of sharing memory. That's another approach. Sometimes you do need coordination, but there's also non-blocking memory. I mean, there's memory that doesn't need a synchronization block that gets visible immediately. And when there is blocking, the last point, when locking is contended, the losing thread must block and just wait for something to finish before it could proceed. All of these things impact performance of the system. So this isn't so bad. Actually, I don't mind this. But the example I'm trying to get out of this is that this lock is too wide. You only really need the synchronized block right here around the around querying the attributes option. And after that, you don't need it. So to have it on whole method was actually unnecessary. It's overly wide. If you are dealing with a lot of lock contention and you see performance being impacted, you might want to look for your synchronized methods and see if you could lower the duration of your lock. Tactics for performance and threads. I don't have them all on here, do I? Well, reduce lock contention. I just kind of showed you here how you could do that. Reduce the duration from which the lock is held. Reducing the frequency with which locks are requested. That's a little trickier to control, but sometimes you can throttle your application that will prevent that from happening. And I think this was alluding to what Chris was saying earlier, is you could replace exclusive locks with coordination mechanisms that permit greater concurrency. You could use an atomic variable, which could be shared by multiple threads without worrying about it, or you could use a read-write lock, and maybe you only have reading and they're not blocking at the same time, and have the write lock go at the small little part of the system. This is again alluding to the previous example. You could reduce the scope of a lock and get it in and out quickly. This is harder to do, but you could split. This is actually dangerous to do if done wrong. You could use multiple locks as opposed to just one lock and attempt to stripe your system the way the concurrent hash map does. Concurrent hash map uses lock striping by having 16 locks and protects the bucket of end locks with the number n mod 16. Not to the third power, that's the reference. That's 16. So when you have multiple threads accessing a bucket in the map, you could have 16 threads accessing it, and they land on different buckets. Well, they're all executing without blocking. Again, you don't have to use locking. You could use more concurrency-friendly techniques such as concurrent collections, read-write locks, immutable objects are great for concurrency programming, and atomic variables, and volatile. Whenever you're trying to work on performance, you will inevitably find yourself trying to monitor the CPU to try to figure out what's going on. And the things to look for, if the CPU is being used, you'll see the little bar go up, right? That's a good thing. But if it isn't, that could be because of a concurrency issue. Or it could be because of insufficient load, focus too much on I/O, external network call that you're also blocked on. And this is the bad situation that we could fix. It could be lock intention, which is why your CPU utilization is not as high as it should be. I think this is the least understood concept in concurrency programming. I run into a lot of senior engineers that are very smart, intelligent people that don't understand this. And it's the concept of memory visibility. And I'll just read this verbatim here. When reads and writes occur on different threads without synchronization, there's no guarantee that the reading thread will see a value written by another thread on a timely basis or even at all. When I bring this up to people, they act like I'm tripping on something. They're like, what are you talking about? It's going to get there. And I'm like, no, it won't. They don't understand memory visibility. A lot of people don't. A lot of people just think of locks as mutual exclusion, meaning I cannot have two threads call this method right here on this shared memory at the same time. That way, my values are not corrupted, like my account example that I keep on bringing up. But locking is not just about mutual exclusion. It's also about ensuring that the variables that are in the caches, that are in each thread, that each thread uses in the processor, that all that gets propagated correctly through the threads. And that's what memory visibility is about. And the only way to address memory visibility on the Java platform, actually, I'm going to touch on that in a moment, is a synchronized block, a lock, a volatile variable, or an atomic variable, if it's mutable memory. Now, another point that I want to make about this is that these concepts of memory visibility and synchronized blocks and mutual exclusion, all of that, this is actually across language issue. I haven't seen a language that this does not apply to yet. And if it doesn't apply to, it's because they're handling it for you under the covers. But that's really what's going on there. I speak to Go programmers who naively say its concurrency framework is handled for you. But actually, no, you could still have a shared mutable variable, launch a Go routine, and not use you're not copying the value to its queue that it has. You're just sharing a shared variable. It's still possible to do that in Go, and they have mutual exclusion blocks in their library for this reason, because it will address the visibility concerns too, not just mutual exclusion concerns. All right, this is more about how I like to divide my view of concurrency programming. I try to divide it into 3 different themes. One of them is how do I share the data and all the things available for me for doing that? How do I signal and do coordination? And how do I actually get the work done? And the way you share is using synchronized or reentrant locks, atomic types, concurrent collections, blocking queues, final, immutable objects, thread locals. A pipe is actually a way of sharing data between 2 threads. And then there's signals. A lot of you guys don't have to use this unless you do really low-level concurrency programming, but it's all in the JDK. There's interrupt, wait, notify all. This is the old way of doing it, but it's still there. Countdown latch, cyclic barrier, semaphore, and then there's the location where all the work happens, which is you have your runnables, your threads, callables, future tasks, executors, and completion services. It's important to know how this all works together and what's going on. So I think it's pretty self-evident. So this is a variable, and this is a thread. Here are some tactics we're sharing. Favor statelessness. Well, did I go over this already? I think I did. I might have copied this on. All right, I'll just say it anyway. So favor immutability, encapsulate synchronization in that order. So first, aim for statelessness if you can. That'll be thread safe. Now, it's probably not good enough for your application. You probably can't make it stateless because it's Java and people don't program that way in Java. Try to make things immutable as much as possible. That could be great. There's a real potential for that, actually. Encapsulate synchronization. I say in that order because once you start encapsulating synchronization, things can go wrong, whereas the other 2 are actually thread safe. Keep in mind that a mutable variable that is used only in 1 thread is going to be thread safe. Address your visibility concerns that I keep on talking about memory visibility when there is a mutable variable that is shared. It's not just about mutual exclusion. And volatile only addresses visibility. But atomic classes address visibility, and they also support compound statements, which allow you to share and do computations on the value itself. Understand that only a lock or a synchronized block can safely guard multiple variables or provide mutual exclusive memory access. So that means if you have multiple variables that need to be updated in 1 call, well, you're going to use a lock for that. There's no other way to really do that. Now, I doubt many people have run into a situation where you use a, or you have, actually, it does come up a lot, never mind. When you need to provide a sequence of data between two threads, you could use a blocking queue for that. This is a very common solution. Less common is using pipe input stream, pipe output stream, but that's actually what it's for. You have one read the data from the file in a piped input stream, I think, and then you, it's been a while. Signals. Signals refer to communicating and coordinating the acquisition and relinquishment of a lock. You're encouraged to use the actual lock object, which has two methods, signal and await. You say, give me a new condition, and then you call signal and await with it. This is low-level concurrency programming, and I'm not going to go over examples here, but I'll just mention it. But there are some tactics to keep in mind. You know what? I don't have the information to back this one up right now. Let's see. Yeah, this is a good tactic. If you need to implement a state-dependent class, one whose methods must block if a state-based precondition does not hold, the best strategy is to build upon existing libraries, such as semaphore blocking or countdown latch. Try to do this before you start using conditions and locks and await notify. If you could solve your problem using these classes first, it might be easier for you in the long run. But if they don't have if they cannot sufficiently solve a problem for you, then use signals. I already mentioned this, but the sleep and pray anti-pattern doesn't solve any race conditions. Anytime you see that in the application code, it is broken. A correct solution would instead use a signal, latch, or cyclic barrier, or other similar construct. Oh, yeah. I like to manage my threads. I don't like to launch them into space. I discourage people just making threads start in the middle of somewhere. I want to throw them in an executor so I can account for them and shut down gracefully. So that's all I'm trying to say here with work.
Set data.
Well, yeah, I mean, there's that argument.
No, I'm just asking.
I have to look at what happens when it's shut down, and I mean, if it's something that I have to really worry about, then that's cool. I would only put stuff that you don't have to worry about it stopping in the middle inside of a daemon, but when you want to make sure that your system, you see, you only want to put stuff that really is auxiliary and could get and have its work cut out in the middle of it as a daemon. But a lot of times people don't want to lose their data. So if you're working on something a little more critical, you don't put it in a daemon. So I, as a personal best practice, don't use daemons. But you know, we have teams and people have different point of views, and people like to go with the solution that they created, and I don't want to always have my way. But if I wrote it, I wouldn't have introduced a daemon. Tactics. So just adding more threads doesn't make things faster. There's actually a calculation for it. A bound. Let's see, what are the variables in here? N is the number of processors. And F is the number of what? It's a fraction of calculations that must be performed serially. As you increase the number of threads, I guess, not just processors. That could be the threads. You're going to be bound by the amount of serial code in there. It's going to converge to 1 over F. So just say, oh, I have work. Oh, it's not going fast enough. Another thread, another thread, another thread. The serial aspects of that computation, if you could actually find a way to measure that, it's going to be 1 divided by that value. And that's your bound. So don't always think that introducing threads to make things faster is going to work. There are limits to that. That's it. I was planning on writing another presentation called Breaking Bad, which was going to cover the solutions to these problems, but I never got there. And I thought covering how to recognize the problems is good enough, actually. I hope you all learned something. I'm sure you all did, because this is quite a heavy topic. Are there any questions? Okay, thank you. Now, next month, LAJUG will have a meeting on Groovy, Grails, and Micronaut by one of the Grails committer, Jeff Brown, who works at a company called Object Computing Incorporated.
New home for Grails.
It is?
Yeah.
The new home for Grails. So,
Yeah, Pitfalls coverage. Pitfalls used to support. It got sent over to API.
and so I hope to see you all there. And
Micronaut's pretty cool. It's a framework for like a micro framework. Got a lot of thought.
bye, LAJUG.
Yeah.
Stopping the broadcast.